I'm Evan DiPietro. If you haven't talked to me yet, I'm pretty much always here. I'm one of the organizers for this meetup. I work here at AWeber. You can find me online at Evan DiPietro on Twitter, Evan DiPietro on LinkedIn. If you pretty much just Google Evan DiPietro, there's only 2 of us on Earth apparently, and the other one's like a 16-year-old hockey player, so it should be pretty easy to find me. So the talk I'm giving here is service workers. The full title is Your Offline First Cache Utilizing Push Notifying Background Dwelling Friends. So that's kind of a mouthful, so just service workers. If you don't like Batman, you're probably going to hate my talk. Somehow Batman ended up in my talk, and I just kind of went with it. So that's where we're at. So you might be asking already, what are service workers? Because probably most people aren't familiar. Does anybody know what they are before I keep going? Okay, so there's a few. All right, so at its very core, service workers are just scripts that run in the background. They're JavaScript that is running an entirely separate thread from what's going on in your browser and really can't interact with your browser at all. It can be a network proxy layer. So you can actually manipulate your requests that are going out through this layer of JavaScript that's going on. You can interact with browser cache in a cleaner way than you have been in the past. And essentially, they're shared worker's shadowy cousin. And I say that because, like shared worker, they both run in their own global script context in its own thread usually, and isn't tied to a particular page and has no DOM access. But unlike shared worker, there's a version upgrade system for these. They can terminate and resume, and they're event-driven in the background, and they can run without a page entirely. So it attempts to deliver on the promises of Google Gears, Dojo offline, and HTML5 app cache, which are all things that have sort of faded into the background for the most part. So what can we do with these? One of the cool features here that I really like, and I'm going to focus on in this demo tonight, is push notifications. That's probably one of the more complete and sort of standardized features for what it's worth. Progressive web apps. So progressive web apps are something that Google's pushing really hard now. And progressive web apps, their definition is that they are experiences that combine the best of web and the best of apps. They are useful to users from the very first visit in a browser tab with no install required. It loads quickly, even on flaky networks, and sends relevant push notifications, has an icon on the home screen, and loads as a top-level full-screen experience. So what does that mean? That pretty much means that it loads up like an app. It's a website that you can visit and then pin to your home screen. It'll have an icon and behave just like an app for the most part. And then that's where background sync starts to come in. Background sync allows this service worker in the background to do things that you would normally associate with an app, such as fetching data in the background and doing things without an actual app or browser, in this case, open. Request hijacking goes back to when we were talking about that proxy layer. You can intercept those requests and manipulate them and do whatever you need to do there in order to create your experience. And finally, caching, which I already touched on. So for a demo, it was just a push notification app originally that somehow became a bat signal app because I ended up on the Batman theme. Let's see if I can get this to work, because there's a good chance that it's going to display on the wrong screen. Come here. All right, so this app, we've made a bat signal, and I already tested it earlier, so let me just refresh this. So the first thing we have here is it just says that it's online with a current timestamp. I'm probably going to hit this button, and the push notification is going to show up on my other screen, and it's totally going to ruin this, but I'm going to try it anyway. And we wait a second and hope that it works. And I don't get a push notification anywhere because it's probably behind the slides. Let me try that again. Let's kill this, because now I'm really curious. And not my code, but the browser. Wrong browser, this browser, push the button. Yep, they're on my other screen. Okay, that's really unfortunate. But what we can do here, let's see how many technical difficulties I can have during one presentation. Now it'll work. Yeah, you can see it up there in the corner, our little bat signal notification. So the part that you'll have to trust me on, since I'm running this all on my computer, is that if you actually went out to DiPietro.github.io/badsignal and hit the button, it would send me a push notification here. So let's get a little more interesting with this now. So we're online, so we'll turn this off. So before everybody spams me, so I just went offline. I turned my Wi-Fi off, and you can tell that the application knows system offline. So what do you think happens when I hit the button now? We're going to hit the button. So press the button, signal sent. So what just happened? So it actually did send the signal to the service worker. And in the background, I'll show you how this works a little later, but what's called the sync function of the service worker is actually waiting to sync this up as soon as we have network again. So when I turn my Wi-Fi back on, as soon as it connects, system online, and there's all my push notifications, some of which were probably sent by you guys. And I'm fantastic. That's great. How much did you spam me? Anyway. So that's why you usually don't publish an app in that way. That's great. All right, so let's get back to this. Where's my... Let's open somewhere else. Fix my screen mirroring. Sorry for all the technical stuff. A separate display. Probably gonna run long from messing with all this. Pull my notes back. Okay, cool. So technology, man, how does it work? Okay, so the gotchas of this. No DOM interaction, like I said earlier. Everything you are going to do with this, you're going to have to interact with it via requests and using that proxy layer. So you could do some interesting things there with AJAX requests and using it as a proxy layer and interacting that way, but no direct DOM interaction. HTTPS only, so they want you to be secure about this. Probably a good standard to have. For local development, it will accept localhost, so if you're just doing things on your own machine, it'll work as well, so that's cool. Makes sense. Limited browser support, I'll touch on that in a minute, we'll go through it. It's very limited, and you have to be aware of the life cycle of these, which I'll talk about a little bit here. So how does this work as far as the life cycle? So when you load up a page, the first thing that happens is it parses the service worker JavaScript, and then it starts installing it. Oh wait, I have better notes on this. So it first starts parsing it. The browser looks for the entry point on the script and gets started. And then installing is a step that you can hook into, and you can cache whatever files you want to there. Typically that's where you'll start creating your sort of offline first web experience, and you can cache all the things that you would need to be able to load these pages offline. Then there's installed and waiting. So installed and waiting is when the worker is installed but not yet active. So what's going on there? Well, what happens is if there's any previous workers that are already active, it will not just jump in and take their place. It'll actually sit there queued behind these previous workers. So then there's activating. Activating is another step I think you can hook. It's triggered when the previous worker releases. So that's when this new service worker finally takes its place and starts becoming your active worker. Activated is when it's finally in control, and that worker is now your current service worker, and it is your proxy layer, and it's doing its thing. And redundant is the final step. It's either if the install fails, or the old worker that's now in a state of redundant because it's just sitting there ready to go away entirely. So support. It makes Batman sad. these yellowy greens, that's not complete support, that's partial support. Nothing actually has finished supporting this yet. So Chrome is sort of at the forefront of this. They've been pushing really hard. Firefox, I think, has pretty good support too. And as far as mobile, it's mostly Android. You're really not going to have great support for this at this point. And I can show some code if I have time. I have no idea how long I went because my speaker notes clock reset. And I do have some resources at the end. Do we have time to look at code? I don't know.
I like code 32.
How am I doing? 32? I guess I am kind of at time. Well, first I'll just tell you what the resources are. Jake Archibald, if you don't know who he is, he's very involved with service workers. He has an amazing amount of resources on his GitHub. Specifically, he has github.io/isserviceworkerready, which is basically everything you could possibly need. It's actually a pretty slick-looking website. Is service worker ready, and he has stats, spec. If you look at resources, absolutely like every decent resource you would need for this. So that's pretty much a go-to place when it comes to this. And then also the actual Google I/O talk that I saw that sort of started inspiring a bit of this. That's a 50-minute talk. It's pretty meaty, but if you actually want to see what they did to get everybody hyped about this, that's probably a good way to go. What I would like to show you about bat signal here is if we hop into our inspector and we hop over, I don't know how much you're going to be able to see this. In resources, this is where you can actually see your service workers. You can see this one's in the activated state right now, and you can see the URL it's associated with. You can see the different states: installed, waiting, active, redundant. And then, so yeah, if there were any kind of errors here or anything changing, anything going on, it would show up here as well. As far as what this actually looks like, actually I can open that in my editor. So this is the bat signal. Is that readable at all, maybe?
Yeah.
Cool. So the service worker itself, you can sort of see those steps I was just talking about. At the very top, you can see the install event listener. And this is all very much like promise-based. So you'll see that there's like, so for the install, it's going to wait until the caches can open, and then it's going to start caching things. You can version those caches so that you can kick old stuff out of there. For this example, I just cached the logo, the JS, like pretty much all of the static assets on this. So then let's look at this fetch event listener here. I'm going through this pretty quickly because I don't have a ton of time. The fetch event listener is what's actually going to intercept those requests. I left some commented out code in here as if we were going to intercept the Batman logo. So you can actually look at the request, what that request URL is, and then you can do an event.respond with and respond with whatever you want. So in this example, you would be intercepting that Batman logo and responding with a Joker instead, keeping with the Batman theme. But in most cases, you'll want something like this, and this is what's going to check your caches and match against those. So it's going to look at that request, match against your caches, and then return either from the cache, or it's going to go out and actually fetch it from the network if you don't already have it in the cache. So what that's going to do is it's going to make anything that's already in the cache lightning quick to load, as well as provide your offline support and everything. This is the signal sync. This is what takes care of, well, it's just sync. I called it signal sync for my event. This is what's going to actually take care of queuing up those events in the background. You can see it's going to do wait until, and then I have a fetch API call there. So since fetch API returns a promise, we can wrap it up and wait until like that, and it works nicely. But that's what's going to take care of our retrying in the event of a network outage or whatever's going on there, and make sure that this actually functions nicely. It's also what's going to work in the background with a browser closed or anything else like that. In this case, there's no timer or anything on it, so it's just going to fire as immediately as it can. But if you're on a mobile device, for example, that would be what's going to sync this up in the background. And as I said, this down here, just fetch API, nothing particularly shiny or fancy. What you will note though is what this actually uses behind the scenes is Google's cloud messaging service. It used to be Google Cloud Messaging, and then they acquired Firebase, and now it's Firebase Cloud Messaging. But basically, every single application that registers gets a address, this gigantic to address. In my case, I cheated and did that ahead of time. But what that is when you go to a website and enable notifications, push notifications, it assigns the client a unique address. So normally you would want to do something with that, send it up to a database somewhere so you actually have those so you can publish out push notifications. But in my case, I'm just keeping it static. Authorization key, that's just a key for my app. I don't care if you see it, it's not anything special.
So that's why we're not getting the push notifications when we're at that site.
Exactly. But what you could do, so I have, if you wanted to play with this a bit, Bat Signal client. This is where the push notifications are actually registered. This is important to note since it's the other half of the equation. And I did this ahead of time because it isn't pretty on the demo. You can see this has its own set of service workers as well. And this is the service worker that's receiving the push notifications. If you were to go to this and hit this yourself, when it enables, you'll see your browser gives you a like accept or deny sort of thing. You can, of course, code around that with catches for all of these events. But once that's done, it actually will spit out the endpoint URL into the console here so that you can play with that. So in my case, if I did this again, it would actually destroy my demo because it would reassign that address and then it wouldn't work anymore. But if you wanted to play with it, that's certainly something to do with it. Yeah, I'm going to stop talking now because I'm probably way over time. Anything else you want to see with this? Questions, comments, concerns? I know I went pretty fast. I guess I can, yeah.
Pretty cool stuff.
Excellent. Cool. Thanks.